let's continue with our discussion on the topic of rate, ratio, proportion, and percentage. Today, we are going to deal with rate. What is rate? Now, rate is a quantity that compares how a quantity changes relative to another quantity of a different kind. How a quantity changes relative to another quantity of a different kind. Now, an example. A car can consume petrol at the rate of 0.2 liters per kilometer. Now, in that statement, we are comparing liters and kilometers covered by a car. So that is a rate. The rate at which the car consumes fuel. Then other quantities which are, we can say their rates are like speed. Speed is normally distance divided by time. So, distance can be given in kilometers, time can be in hours. So, this is a rate because it is the distance covered per unit time, per time in hours. Then we can also talk about density. Density is normally calculated by dividing mass by volume. So, the units for mass can be kilograms or grams, let's say kilograms, and the units for volume are centimeters cubed. So, density is the amount of mass per volume. So, kilograms per centimeters cubed. So, those are quantities which help us determine what rate is. Now, let's look at an example on how we work out questions involving rate. So, example 1. A car travels 50 kilometers in 30 minutes. At what speed does it travel in kilometers per hour? Now, here is a situation whereby we are given distance in kilometers and time in minutes. So, in order for us to be able to calculate the speed in kilometers per hour, we must first change these minutes to hours. And we know 30 minutes is equivalent to half an hour. So, we can say our speed will be equal to distance, which is 50 kilometers, over time in hours, which is half an hour. Half an hour can be written like 0.5 hours. So, this is going to be equal to 50 divided by 0.5. Let's remove the decimal by multiplying the numerator and the denominator by 10. So, this is going to be equal to 500 divided by 5. So by 1 by 5, 100. Therefore, the speed for this car will be equal to 100 kilometers per hour. Are you here? Yes, 100 kilometers per hour. Now, usually motion. So the speed at which a car begins at is not the same speed it is going to have all along to the end of the journey. This is because when you are starting off a car, you start at a low speed, but with the time you accelerate. Therefore, acceleration is a factor which we should consider whenever calculating speed. And that's why normally we don't call the speed of a journey speed, but we call it average speed, because of the fact that at the beginning of the journey, the speed is slow. It's slow, but with the time the car will accelerate, and towards the end of the journey, they will still again have to slow down until they stop. Therefore, normally you'll come across the word average speed. Now, let's talk about velocity. Velocity is another quantity which is a rate. And velocity is the distance covered in a given direction per unit time. Distance in a given direction. And that distance in a given direction is normally referred to as displacement. So velocity is equal to displacement divided by the time. So the difference between speed and velocity is that speed is just general. Just the speed a car, a person, or any moving body takes to cover a certain distance over a given period of time. But when we talk about velocity now, this has to be specified. It is speed towards where? It is speed in which direction? So the only difference is velocity has direction, speed does not have direction. So let's look at an example on velocity. So we say on a straight road, that example 2 now. On a straight road, a cyclist travels 100 meters in 10 seconds. In 10 seconds. Calculate the velocity of the cyclist. So, how do we go about this? First thing we know, velocity is equal to distance over time. And this distance is in a specified direction, which we call displacement. So this cyclist is going on a straight road and travels 100 meters in 10 seconds. So 100 over 10, and this is going to give us 10 meters per second. So that is velocity, and in the first case it was supposed to be in meters per second. What if you are asked to calculate the velocity in kilometers per hour? How do you go about this? So what you're going to do here is that you first convert your meters to kilometers. So these are 10 meters per second. Convert these meters to kilometers. You divide by 1,000. Then per means divided by. Changing seconds to hours means dividing by 3600. So divide by 3600. Is it so? No. 1 hour is equivalent to 3600 seconds. So this is 1 second. So 1 second is equivalent to how many hours? So it's going to be 1 over 3600. So these seconds ni 1 over 3600. 1 over 3600. So this is like saying 1 over 100 times 3600. Then this will go. So this is going to be 36 kilometers per hour. So that is how you do it in order to change meters per second to kilometers per hour. First of all, convert your meters to kilometers by dividing by 1,000. Then this per means divide by. Per second means 1 second. So we need to know 1 second is equivalent to how many hours for us to be able now to calculate this value in kilometers per hour. Now, we move on to something called acceleration. Acceleration. What is acceleration? Now, acceleration is the rate of change of speed, of velocity with time. The rate of change of velocity, with time. Now, we've just said that at the beginning of a journey, or when you start a car, it will like move slowly before it gains momentum, and at the end of it, it will slow down until it stops. So, acceleration is the rate of change of this velocity, and therefore, the formula of getting acceleration is equal to change in velocity over the time taken. Change in velocity over the time taken. Now, when we talk about change in velocity, it means the final velocity, which is referred to as v, over the initial velocity, referred to as u. So the formula for acceleration now becomes v minus u over time. V minus u over time. Now, let's look at an example involving acceleration. Now, going uphill and downhill, going uphill and downhill, the velocity of a cyclist was 5 meters per second. 10 meters per second respectively, and 10 meters per second respectively. If the cyclist took 20 seconds, if the cyclist took 20 seconds to climb up and down, to climb up and down the hill, calculate the acceleration of the cyclist. Now, this is a very easy question. We have noted that in order to be able to find acceleration, we must know the final speed or final velocity minus the initial velocity over time. Final, we represented it using a V. So V minus U over time. V always means final velocity. U is initial velocity divided by time. So the final velocity of this cyclist was 5 meters per second and 10 meters per second, going up and down. So he went up and down. So the final was 10 meters per second minus the initial, which was 5 meters per second, and the time it took for Bob was 20 seconds. So it's going to be 10 minus 5, which is 5 over 20 by 2 by 5 1 by 5 4, a quarter, which is going to be about a quarter is 0.25. The units are meters squared, meters per second squared, meters per second squared. So that is acceleration. That is the acceleration of this cyclist. Now another question. An aeroplane flies from point A to point B 1 kilometer apart in 5 seconds. Calculate the velocity in meters per second and in kilometers per hour. So let's start with part A, velocity in meters per second. So velocity is equals to distance in a given direction over the time taken. Now in our case, our distance is 1 kilometer and the time is 5 seconds. So we must convert our kilometers to meters by multiplying by 1,000. So this is going to be 1,000 meters divided by 5 seconds. So this gives us a velocity of by 5 1, by 5 200. So it's going to be 200 meters per second. Now on the other hand, for us to be able to calculate the velocity in kilometers per hour, then we need to convert these seconds to hours. So we can start by saying that 1 hour equals 3,600 seconds. So 5 seconds is equivalent to how many hours? Cross multiply 5 times 1 over 3,600, and this is going to be equal to by 5 1 by 5, this is 7 by 5 to 720. So 5 seconds is the same as 1 over 720 hours. So our velocity will be equal to distance. The distance in kilometers is 1 kilometer. Then divided by 1 over 720 hours. So this is the same as 1 times the reciprocal of 1 over 720 is 720. And then this gives us 720 kilometers per hour. Look at this question, which was tested in a KCSE paper back in the year 2020 on rates. Water flows from a tap at the rate of 25 centimeters cubed per second into a rectangular container of length 60 centimeters, breadth 30 centimeters, and height 40 centimeters. If at 6 p.m. the container was half full, what will be the height of the water at 6:04 p.m.? Now, let us first start by finding the volume of this rectangular container. And we know volume of a rectangle equals length times width times height. So this is going to be equal to 60 times 30 times 40. Now this gives us a volume of 60 by 30 by 40. It gives us 72,000 centimeters cubed. That is the total volume of this rectangular container. Now what we need to do next is to find, using this rate, we find the volume of water that entered that container between 6 p.m. and 6:04 p.m. So this is a difference of 4 minutes. 6:04 minus 6 equals to 4 minutes. Now if you convert these minutes to seconds, it's going to be 4 times 60, which gives us 240 seconds. And the rate at which the water enters into that container is at the rate of 27 centimeters cubed per second. So 1 second is equals to 27 centimeters cubed. So how much water will have gone into the container in 240 seconds? So we can cross multiply this and say 240 times 27 equals 6480 centimeters cubed. That is the volume that entered that tank in those 4 minutes. And the question is, what will be the height of the water at 6:04 p.m.? So here we still maintain the length and the breadth. The length and the breadth of the container as 60 and 30. So 60 times 30 times a height we don't know should be equal to a total of, we were told at 6 p.m. the tank was half full. So half of 72,000 is 36,000 centimeters cubed. And 36,000 centimeters cubed plus this amount of water which entered within those 4 minutes, which is 6480. So this gives us 42,480. So in order for us to get the height of this container, now we shall equate this volume of the container to 42,480. So our height will be equal to 42,480 divided by 60 times 30 is 1800. So our height equals 42,480 divided by 1800. That gives us 23.6 centimeters. That is the height of this container. So I would wish to give you some more questions for your practice on rates. Yeah, so copy the following questions and attempt them for you to be able to evaluate yourself on whether you've understood this concept of rate, or maybe you need more practice. Yeah, so for your assignment, attempt this question, which is also a question from a past KCSE exam. A rectangular tank of base 2.4 meters by 2.8 meters and a height of 3 meters contains 3,600 liters of water initially. Water flows into the tank at the rate of 0.5 liters per second. Calculate the time in hours and minutes required to fill the tank. Yeah, so attempt that one and see if you can be able to get it right, and do as many questions on rates as possible. They are available on KCSE Med Familia and many other revision books, and I believe all shall be well with rates. In the next lesson we shall now deal with ratio, and till then, have a nice time. Bye.